We are beginning our unit on factoring quadratic expressions. We will start by talking about greatest common factors. So that's something we can divide all of our terms by. So let's talk about our rules of divisibility. A number is divisible by 2 if the last digit is even. We'll know a number is divisible by 3 if we add up all of the digits and that sum is divisible by 3. It's divisible by 4 if the last two digits are divisible by 4. It's divisible by 5 if the last digit is a 0 or a 5. And it's divisible by 6 if it meets both the rules for 2 and 3. So to review that, to be divisible by 6, it has to have the last number being even. And then also, if you add up all the digits and that sum is divisible by 3, then it is divisible by 6 if it meets both criteria for 2 and 3. And then it's divisible by 9 if you add up the digits and that sum is divisible by 9. And then it's divisible by 10 if the last digit is a 0. So those rules should help you to figure out a greatest common factor because we're thinking about what we can divide both numbers or both terms by, or all 3 or 4 terms. All right, so before we factor, we're going to warm up by multiplying monomials or distributing. So when we take x times the expression 4x plus 9, distributing x times 4x, we get 4x squared, and then x times 9 gives us 9x. Distributing the negative 2n here, remember that there's an understood 1 exponent here, and when we take negative 2n times n squared, we add the 1 and the 2 on that like base, so we get negative 2n cubed. And then when we take negative 2n times negative 5n, remember that a negative times a negative is positive. That gives us positive 10n squared. And then taking negative 2n times positive 2 gives us negative 4n. Distributing 5x cubed y times x to the 4th would give us 5x to the 7th y, and then 5x cubed y times negative 3xy, multiply the coefficients. 5 times negative 3 gives us the negative 15, and then we add the exponents on like bases. So that's how we get x to the 4th and y to the 2nd. So remember, there's an understood 1 exponent here on this y. There's an understood 1 exponent right here with the x, and an understood 1 exponent right there with the y. So that's multiplying. What is factoring? Factoring is going from the standard form that we ended with up here in all of these expressions to the factored form, which is writing it as a product. So here we have, in the factored form, we have 6x times the quantity x minus 2. So taking it from this and breaking it up into this monomial times this binomial here. So it's like breaking up a polynomial into a product of monomials and or polynomials. And this is not an official math word, but I think of it as undistributing. If you type that out, you're going to get a red line under it because it's not an official word. That's just something I use to describe the factoring process. It's like going backwards from what we did right here in the warm-up. Instead of distributing, we would be undistributing and taking it back to that breakup of a product of this monomial and binomial. So in order to factor out a GCF, to identify what that greatest common factor is, first you want to look at those coefficients and figure out the greatest common factor with them. So that's the largest number. You can divide them both by. I can show you how to find a GCF on your graphing calculator, or if you know your multiplication facts, you'll probably be able to figure it out on your own. And then after figuring it out, after looking at your coefficients and figuring out their GCF, now you look at the variables. The variable must be present in all of your terms, and then it would be the one with the smallest exponent. So after you've identified the greatest common factor, now you divide all of your terms by that greatest common factor, and that will be your first factor. The second factor will be what you get when you divide all those terms. Okay, so you'll put those after you divide, you put those together in parentheses. All right, so looking at number 1, look at our coefficients 6 and 42. Obviously 6 is divisible by 6, and if we take 42, it's even, and if we add up the digits, 4 plus 2, we get 6, and that is divisible by 3. So they're both divisible by 6. Now looking at the variables, this one has an x, but this one does not, so they don't have an x in common, so the greatest common factor is 6. So we will divide both terms by 6, and then we would the greatest common factor we write first, and then in parentheses we write what we get when we divide both of those terms by 6. So 6x divided by 6 gives us x. 42 divided by 6 gives us the 7. Look at your coefficients 16 and 20. Those are both divisible by 4. Next, look at your variables. This has a variable of y, and this is a variable of x, so they don't have any variable in common. So our greatest common factor is 4. Dividing both of those terms by 4 gives us 4y squared minus 5x squared. Looking at number 3, 56 and 24 are both divisible by 8. Their greatest common factor is 8. And then also notice they both have an m. Okay, this one has an n, but that one doesn't. So they don't have an n in common. So remember, greatest common factor is what they have in common. So our GCF here is 8m. So factoring out the 8m, in parentheses, we have what we get when we divide both of those terms by 8m. So remember, we divide the coefficients. 56 divided by 8 gives us 7. M divided by m, those cancel out. And then 24 divided by 8 gives us 3. The m's cancel out, so we still have the n on that one. Now we're looking at all three terms. We got our coefficients 2, 8, and negative 12. Those are all even, so they're divisible by 2. And then they each have an x in them. The least amount occurs is once, so we go with x to the first for our greatest common factor. So 2x is our GCF. So we're going to divide all of those terms by 2x. We write that 2x first, and then what we get when we divide the first term by 2x would give us x squared. The second term divided by 2x gives us 4x. The last term divided by 2x gives us negative 6. So you'll know your answer is correct if you distribute and you end up back with the original expression. So when I take 2x times x squared, I would get 2x cubed. When I take 2x times 4x, I would get 8x squared. When we take 2x times negative 6, we would get minus 12x. So that's how we check by distributing. In number 5, we've got 3 terms going on. Let's look at our coefficients. We've got negative 12, negative 18, and positive 6. Those are all divisible by 6. And if your leading coefficient is negative, factor out a negative. So I'm going to factor out negative 6. Next, I'm going to look at my variables. We have an x in the first, an x in the second, and an x in the last. And then looking at the y's, I don't have a y in all 3 terms. So the x is in all of them. The least amount of times is once. So our greatest common factor here is negative 6x. So again, because the leading coefficient was negative, I'm going to factor out negative 6. So dividing all of those terms by negative 6x would give us positive 2x squared y squared plus 3x minus 1. Excuse me. All right. Number 6, look at your coefficients, which are 15 and 45. Those are both divisible by 5 because they end in 5. And then if we add up the digits, 1 plus 5, I get 6. So it's divisible by 3. If it's divisible by both 3 and 5, then it's divisible by 15. So let's see if that also works for 45. 4 plus 5 is 9. 9 is divisible by 3. So 45 is divisible by both 3 and 5. Therefore, it's also divisible by 15. So then we move on to the variables. We have x to the first here, x to the second here. So they both have an x. In our GCF would be x to the first. Then we've got y cubed here, y squared here. So y squared would be part of our greatest common factor. So that's 15xy squared. Dividing those both by 15xy squared, we would have y plus 3x.